Elementararies, we are going to be looking at an essential question today of how can we tell what type of solution our equations will have. Over the last couple of days, we've been looking at big, long Herkin problems where we've isolated the variable and we've ended up with one solution. So these types of problems where it says x equals something or y equals something or g equals something, like this problem here from before, all of these types of problems have one solution. There's only one answer that makes the problem true. Today we're going to be looking at what happens when you have other types of solutions and what those other types of solutions are. So the first thing that we're going to look at is a problem that says 3 minus 4x equals -7 minus 4x. Okay, so in this problem, we're going to solve just like we normally would, because if you notice, you have a variable on one side and a variable on the other. So our job here is to draw the line and to move variables from one side, numbers to the other. Now, it doesn't matter what you start with. You can start with numbers, you can start with variables, your choice. You're going to be doing the opposite, so whatever you do, it doesn't really matter. So in this case, I'm going to start with the variables, and I am going to add 4x and add 4x. I now have this zeroed out. I'm going to drop my -7, and uh-oh, my x's just went away, and it says 3 equals -7. This can't be right. 3 does not equal -7. Those two things are not equal at all. This has no solution. So this first type of equation does not have a solution. The reason is because we removed all of our x's. They're gone. There's no x's left. And so because the variables have been totally and completely removed, we're left with two numbers that don't equal the same thing. Therefore, they do not have a solution. Okay, let's look at another problem. So we have another problem that looks like this. Example B. Example B says that I have 3x minus 5 equals 7 plus 3x. Again, I want x's on one side and I want numbers on the other. It doesn't matter what it is that you start with. You can start with either. So for this problem, I'm going to start with the constants, just so you can see that it doesn't matter which one we start with, because I don't like negative numbers as much as I like positive numbers. So instead, I'm going to add 5. That cancels, and I'm going to add 5. I now have 12 plus 3x equals 3x. I'm not done because I still have variables on both sides of my equation. So I need to move 3x by canceling this one. Uh-oh. But look what happens. When I did that, I canceled that one. And now I have 12 equals 0. What? 12 doesn't equal 0. 0 equals 0. 12 equals 12. But 0 does not equal 12. So when they don't equal each other, there is no solution. So the last couple days, we saw one solution where the variable equaled one specific number or integer. Here we have no solutions because they don't equal each other. Okay, so now what I want you to do is your try-its for this type of problem. So go ahead and solve these. So we have try-its. Try-it number 1 says 2x plus 1 equals 2x minus 1. And then on this next problem, try-it number 2. Okay, we're going to use the distributive property here. It says 6 groups of 5 minus 2v. 2v or not 2v equals negative 4 groups of 3v plus 1. All right, so go ahead and hit pause right now so you can solve, and then you're going to tell me, does it have one solution or no solution? All right, hopefully you start to see a pattern developing. All right, so I'm going to draw my balance line, and I want x's on one side, and I want numbers on the other. So I'm just going to subtract 2x and subtract 2x, and instantly I've canceled out all of my x's, and it says 1 equals negative 1. 1 does not equal negative 1. So this problem has no solution. I have removed all variables. Once I remove all my variables and one side does not equal the other, there is no solution left. Okay, let's check this one where we have to distribute. So we have 30. And we have 6 times negative 2, so we get negative 12v. And we have negative 12v minus 4. Again, it doesn't matter which side you start on. So we could have numbers over here and v's over here. So let's go ahead and start with the v's, plus 4, and I get 34 minus 12v equaling negative 12v. Now I need to move the v's. Cancel. That's 34 plus 12v. Oh my gosh, this one went away too. So this one is 0. 0 does not equal 34. So again, we have no solution. Okay, hopefully already you have started to notice a pattern on how you can tell what type of solution our equations will have. What happened? What was something that you're noticing? So go ahead and check that. How did you do on both of those? Both are no solution. Now we're going to talk about another type of problem. So on this next problem that we're looking at, which is example C says that we have 6x plus 4, and it is equal to 4 groups of 3 over 2, of course, because why wouldn't we have a fraction? We haven't done one of those in a while, mixed in with distributive property. Okay, so let's go ahead and start solving. So again, we want x's on one side and we want numbers on the other. Right now I have both, but I also have distributive property. This I don't need to do anything over here yet because there's no distributive property. So let's go ahead and solve this problem. So 4 over 1 times 3 over 2, x. That gives me 12 over 2x. And then this distributive property plus 4. So 12 over 2x is the same as 6x plus 4. And this side is 6x plus 4. That's kind of weird. Okay, they're the exact same. So now let's look at this and see what happens when we get x's to one side, numbers to the other. Okay, so x's to one side, numbers to the other. So I'm going to start with minus 6x minus 6x. Okay, my letters, my variables are gone. I need to drop down what's left. I have 4 equals 4. Oh my gosh, this is true. 4 really does equal 4. 4 equals 4. So this problem right here, this problem is called infinite. This problem has infinitely many solutions. Oh my gosh, try saying that 5 times fast. So that means that I could put anything in for x and one side will always equal the other side. So this is called infinite solutions. So this problem has infinite solutions. That means that the solutions never end. They will go on forever. That's because if I put 3 in here and put 3 over here, because x is the exact same thing, when I get down to here and I say 6 times 3, I get 18 plus 4, and 6 times 3, I get 18 plus 4. I'm getting the same answer regardless. So when one side is equal to the other, I'm going to have infinite solutions. So even though x disappeared, they still equal the same thing, and it doesn't matter that x disappeared because when I plug a number in for it, it's going to have an infinite solution. So over here, no solution because this side was not equal to this side. That means that if I put a 3 here and a 3 here, they would not equal the same things no matter what. So no solution there. Here, they have infinite solutions because both sides are equal to each other. Okay, let's do one more example before you have a try it of your own. All right, so I need another example of infinite solutions. All right, so we have 1/4 of 8x minus 12. So that means that we have to distribute a fraction all the way through, equals 2x minus 3. So this is good practice right here to distribute this fraction because we have not distributed a fraction yet. So I have 1/4 of 8, or 8 over 1x, like this. And I have 1/4 of 12, so minus 1/4 of 12 over 1. Now I can do 8 over 4x minus 12 over 4. And we're just going to simplify. 8 divided by 4 is 2x minus 3. Oh my gosh. And look, I'm just going to bring this all the way down. 2x minus 3. They have infinite solutions because if I plug something in, for example, this side is equal to this side, I could put a 2 in here. If I said that x equals 2, just randomly, if I say that, I would have 2 minus 3, and 2 minus 3, that's 4 minus 3 equals 1, and 1 is equal to 1. Okay, so it doesn't matter whatever you put in, you're going to end up with the same answer. So this one is called infinite solutions. The solutions go on forever. Okay, I don't have a lot of space right here, but we're going to plug our try it in. So your try it for infinite solutions. I think we're just going to do 1 for that because you can see it right away. All right, so this is going to be try it number 3. And it says 1/2 of 6t minus 4 equals 3t minus 2. Okay, go ahead and hit pause right now so you don't hear me solving this problem. And then when you are ready, go ahead and come on back. All right, if I have half of 6, that gives me 3t. And if I have half of -4, that means I have -2, which is equal to 3t minus 2. Again, I want t's on one side, numbers on the other. So I could subtract 3t and subtract 3t. They cancel each other out, and I get -2 is equal to -2. So this has infinite solutions. All right, how are you feeling about today's lesson? Go ahead and answer your essential question from earlier. How in the world can we tell if our problem is going to have one solution, no solutions, or infinite solutions? Like, how can we tell that? And then put a rating in a box. Where are you at with your learning and your understanding of this process? And then, if you need help, come on back to the Google Meet and ask for help. Otherwise, you may go and work on your practice work. As always, I appreciate all of your hard work, and make it a great day.